So the topic of this video will cover the definition of a derivative. What is a derivative? A derivative is the slope of a function at a given point. For example, for this function f of x, the derivative at some point x is the slope of this tangent line. The definition of a derivative is based off of the slope formula, which is basically the change in y over the change in x. Slope can also be known as a rate of change. A rate of change basically measures how fast one variable is changing in relation to another. For example, in reference to cars, you might say miles per hour, which is a rate of change to measure the speed of a car. So the two types of rate of changes we will look at are the average rate of change and the instantaneous rate of change. The average rate of change is the basic slope formula that we have been using since Algebra 1. This calculates the slope over some interval between two endpoints. So for this function, the average rate of change is the slope of this line that goes through the two endpoints. This line is also known as the secant line. The instantaneous rate of change is what we are learning now, which is a derivative. So it's the derivative at a specific point. So at this function, the instantaneous rate of change at this point is the slope of this tangent line. A real-world example that will help you understand fundamental calculus relationships is one that observes position and velocity. So velocity is simply the derivative of position. So for example, say you have a car that is driving away from home. Its position can be modeled by a function. So let's say you have time on the x-axis and distance from home on the y-axis. At hour 1, the car is 20 miles away from home. At hour 2, 40 miles, and hour 3, 60 miles. So the function can be written as p of t, or the position, equals 20t. So the velocity function is the slope of the position function, because at any given point of this function, the car is traveling at 20 miles an hour. So now back to the definitions of derivatives. There are a variety of definitions that you can find for derivatives. However, all of them are essentially the same thing. We will look at two. The first one is the A definition. The background of the problem that we are looking at is to find the derivative of f of x at x equals a. So this function in the blue is just some function f of x, and the point of interest is this point, point A. So we have a f of a, and that's the point we want the slope of. So first you're going to construct some arbitrary point, x, f of x, and then using those two endpoints, using the coordinates, you will plug that into the slope value. So you'll have f of x minus f of a all over x minus a. This gives you the average rate of change between the 2 points, but we want the instantaneous rate of change at this point. So as x approaches a, the slope of this line m approaches the slope of the tangent line a as x approaches a. So the definition is f of a is the limit of x approaches a of f of x minus f of a all over x minus a. The H definition is similar to the A definition, however, there are subtle differences. So it's the same background. You have some function f of x, and we want the slope at this point of interest, the green point, x f of x. So next you're going to construct an arbitrary point, which is x plus h, and h represents the difference between the point of interest and an arbitrary point. And then you have f of x plus h. Next, you plug in those coordinates using the slope formula, so you have f of x plus h minus f of x all over x plus h minus x, and the x's in the denominator cancel out, so you're just left with h. So h represents the difference between the point of interest and the arbitrary point. As h approaches 0, or as the distance grows less and less, the 2 points get closer and closer, and the slope of the secant line, or the average rate of change, approaches the slope of the tangent line at the point of interest. So the derivative of f of x equals the limit as h, or the distance between the 2 points, goes to 0, of f of x plus h minus f of x all over h. When and how. So this will just tell you a few key pointers or hints that will help you figure out when to find the derivative. So you will find the derivative when the question asks you to find the instantaneous rate of change, or when it'll explicitly state find the derivative at, or to find the slope of the tangent line at, or to find the slope at. Essentially, these are all telling you the same thing, however, they're just worded a little differently. You can find the derivative of the entire function, or if the question gives you an x value, you want to use that x value to find that specific point, or the specific slope, rather. So how to solve for the derivatives, you can either use the definitions or you can use the derivative rules. Using the H definition. So this problem will use the H definition we just found, which is written right here, for a specific problem. So you have some function f of x, which in this case is x squared plus 2, and you want to find the slope at x equals 3. So we have the formula written out, and now what we're going to do is use the function they gave us to write out or to solve for the derivative. So you always want to write your limit notation first. And so for the first term, f of x plus h, you want to substitute an x plus h for any x value in the function given. So our function is x squared plus 2, and you need to substitute x with x plus h. So you're left with x plus h squared plus 2. And then minus f of x, so minus just the function given, so minus x squared plus 2, all over h. So then you also have, next you go to the limit of as h approaches 0, and you want to FOIL out all the terms. Next, you want to combine like terms. So this goes away with this goes away with this, and you're left with 2xh plus h squared all over h. So the goal is to eliminate h from the denominator so you don't have a divide by 0 scenario. So you can factor out an h from the numerator, and then the h from the numerator and the h from the denominator will cancel out, and you're left with the limit as h approaches 0 of 2x plus h, which is 2x plus 0, so you're left with just 2x. So the derivative of f of x at any point will be given by 2x. However, at 3 specifically, which is what the question asks us, we will plug in 3 for the x value, and the slope at x equals 3 is specifically 6. So here are some derivative rules. The most commonly used rule is the power rule, where you have some variable with an exponent, and what happens is you drop the exponent to the coefficient and subtract 1 from the original exponent. Next, you have the derivative of a constant, which isn't really a rule, however, just always know that the derivative of a constant is 0. Next, you have the product rule. So you have the product of two terms, you want to find the derivative of it. So you do the first term times the derivative of the second term plus the second term times the derivative of the first term. The quotient rule, which is the quotient of two variables, you have the denominator times the derivative of the first minus the numerator times the derivative of the second all over the denominator squared. For notation, just a few hints, or not hints rather, but just key facts that will help you. F prime of x is the same thing as df of d of x. It's just different notation, however they all mean the same thing. Also keep in mind that if a function is differentiable at some value a, then that function is also continuous at a. Here's some examples to test out the rules we just learned. So here we have, given f of x equals 5x cubed, we want to find f prime of x. So since we have the variable to some exponent, we can use the power rule. So f of x equals 5x cubed. So f prime of x, we want to drop the exponent to the coefficient, so we have 3 times 5x to the third power. However, we need to subtract 1 from the exponent now. So we're left with 15x squared. Next, we will look at some product rule and quotient rule problems. So say we have an f of x, which equals x squared, and g of x will equals 4. First, we want to find the derivative of the product of two functions. So really, we want to find the derivative of x squared and 4. So you want to do the first term times the derivative of the second. The second is a constant, so the derivative is 0, plus the second term times the derivative of the first. The first term is x squared, and using the power rule, we can determine that the derivative would be 2x. So you're left with 0 plus 8x, so your derivative would be 8x. The last example is we'll use the quotient rule, which is the derivative of f of x over g of x, which is just asking for the derivative of x squared over 4. So you want to do the denominator times the derivative of the numerator, which we determined in the previous problem was 2x, minus the numerator times the derivative of the denominator, which since the denominator is constant, the derivative is 0, all over the denominator squared, so all over 4 squared. So we have 8x minus 0 equals 16, which gives us 8x over 16, which gives us x over 2 if you simplify. So that was examples of some of the rules, and that's all. This video is completed by Rishika, Brooke, and Noah.